viewers, welcome back. So today we have an example on exponential decay. A certain radioactive element is known to decay at a rate proportional to the amount present. If initially there are 100 milligrams of the material present and after 2 years, it is observed that 5% of the original mass has decayed. Find an expression for the mass at any time, the time necessary for 10% of the original mass to decay. When we talk about a radioactive element is a chemical element that's what with an unstable nucleus that decay over time. It's a chemical element. So a chemical element can be uranium, it can be plutonium, it can be radium. So radioactive element decay with what? With time. It's a chemical element that decay with what? With time. So how can we now solve this exponential decay? Remember in our previous lesson when we talk about how we generate exponential decay formula, we have been given that a certain radioactive element is known to decay at a rate proportional to the amount present. If initially there are 100 milligrams, that is our mass, initial mass is what? 100 milligrams. Our M naught is 100 milligram mg. It is observed that 5% of the original mass has decayed. That is 5% of this original mass that we have been given, it has decayed. So this is our original mass we have been given. So 5% of 100 is, for us to get 5% of 100, we have what? 5 all over 100 times what? 100. Because 5% of 100 of this. So 5 times 100 is what? 500 all over what? 100. What are we going to get? We are going to get 5. So that is, it is observed that 5% of the original mass has decayed. We have 5. So the original, this is an initial mass. It means what? We have to subtract initial mass from this 5% that decay in this 100. That is 100 minus 5. We are going to get what? 95. So our M of T will be 100 minus 5. We are going to get what? 95. So our mass, the time of the mass is 95. And the reason why our initial mass is bigger than our final mass, because of what? There's a reduction in mass. That's why we have minus K. That's why we have our constant of proportionality is what? Negative. So our T naught at initial mass is what? 0. Our T naught, that is the initial time of initial mass, is what? It's always 0. As decay, so after 2 years, it means our final time is what? Is what? 2 years. So this is our what? This is our what we have been given. So we have to find the original mass, find an expression for the mass at any time t. According to the formula for exponential decay, we have M of T is equal to initial mass M naught exponential minus KT minus T naught. So our M of T is what? 95. Our M naught is what? 100 exponential minus K. Our T minus T naught is, our T is 2 minus 0. So in this case, we are going to have 95 is equal to 100 exponential minus 2k. So 100 exponential raised to power minus 2k. What are we going to do? We have to divide both sides by 100 so that we can have exponential minus 2k. And then we have to take the lane exponential, natural log, so that lane and exponential will be able to cancel themselves. So we now have 95 all over 100 is equal to 100 all over 100 exponential minus 2k is able to cancel. 95 divided by 100, we have 0.95 is equal to exponential minus 2k. What next? We have to take the natural log of both sides. We have ln 0.95 is equal to ln exponential minus 2k. This will cancel. What is ln 0.95? Ln 0.95 is minus 0.05129 is equal to minus 2k. So we have to divide both sides by minus 2. Our k will now be minus 0.05129 over minus 2. If we divide it by minus 2, we are going to get k. This will cancel. We are going to get k 0.025565. So the number is a rational number. So I have to take it to first significant figure. So our k is our decay of the constant. Our decay of the constant is 0.02565. So we have to find an expression for the mass at any time t. So the expression of the mass at any time t will now be m of t is equal to m naught, that is initial mass exponential minus the decay constant 0.02565, then t minus t naught, that is t. So this is our expression for the mass at any time t. You can take a screenshot of this. So number 2, the time necessary for 10% of the original mass to be decayed. So the time necessary for 10%, so we have 10%. So 10% is 10 all over 100 of the original mass to be decayed. What's our original mass? We have 100. What is our original mass? So 10 times 100, we have what? 1000 all over 100. So 1000 divided by 100, we are going to get what? We are going to get 10. We are going to have 10. So our original mass, that is the initial mass we are given, is what? 100 milligram. So we have to subtract 10 from 100 milligram. If we subtract 10 from 100 milligram, we have 100 minus 10. We have what? 90 milligram. So our mass, our final mass, the time of the mass will be what? 90 milligram. Our initial mass is already 100 milligram. Yes, we have initial mass is 100 milligram. So we have to use this to get the time necessary for 10% to decay. So 10% of inner mass to be decayed, we have 90 milligram of the what? 90 milligram of the what? The time of the mass. So now 90 is equal to 100 exponential minus 0.02565. So we have to find our t. Our t naught is always 0 at m of 0 is 0. So our t is, we don't have t minus 0, we are going to get t. T minus 0, we are going to have t. So that's why we have t here. So we have to divide both sides by 100. 90 divided by 100, we have 0.9 is equal to exponential minus 0.02565 t. So what next? We have to take the natural log of both sides so that ln and exponential will cancel each other. We have ln 0.9 is equal to ln exponential minus 0.02565 t. So this will be cancelled. So we now have, what's our ln 0.9? Minus 0.1054 is equal to minus 0.02565 t. So we have to divide both sides by minus 0.02565. So we can get our t. So what do we now have? We now have our time is minus 4.1. So our time is 4.1. Minus, we're able to cancel minus. So our t is what? 4.1 years. So the time necessary for 10% of the original mass to decay is what? Is 4.1 years. That is approximately to 4 years. So this is